A lot happened to that code over the course of those demos. Let me just summarize for you. First, whenever you see anything involving CARSTAR, look to replace it with string. This is going to be your opportunity to rip out a ton of code that goes to a great deal of trouble copying and comparing and generally handling special cases, and be able to use the same code for the strings as for everything else, comparing with the ordinary comparison operators, combining with the ordinary, say, plus operator. There's a great benefit in this. There are many, many bugs lurking in CARSTAR code, and it's often the place where people just stop reading and take it on faith and move on to the next lines. So turning CARSTARs in samples and tutorials and other people's old code into strings has a big gain for you in readability and in maintainability. In fact, there's a bug in the code that I had in that sample. It has a memory leak. It allocates memory on the free store for the all animals string with new. Nowhere in that code is there a delete. You didn't see it. You didn't look for it. That's what CARSTAR code does to you. Switching it over to strings, it manages its own memory. And if the internal implementation of the string class allocates some characters on the free store, that's its business. It cleans them up when the string goes out of scope. You don't have to manage the memory. And the bug that you never noticed is gone. If you see people using printf, switch it over to cout. It's more type safe, it's more type aware. There's a chance that you may want to drill into some of the capabilities of cout to do things like, how do I format how many decimal places I want? That capability is all there. You just have to look in the documentation. It's another way of expressing the same capabilities. Raw arrays, these things are what make people write rigid programs. They tell you that your own last name can't be the length that it is. They tell you that everybody can have exactly 3 of something, and they can't have more and they can't have less. Changing to vector lets your code be more realistic and safer at the same time. Macro definitions are vulnerable. We've talked about this before. Using enums, especially use a const int if it's a single value, or a const whatever if it's a single value. Consider also putting that static const into a class so that it's scoped to that class and you don't have to worry about name collisions. Hand-rolled loops, especially hand-rolled loops that were going through old school arrays that didn't know their own size. Algorithms. Faster, more expressive, less buggy. It's the right thing to do. Function pointers. Hopefully there's none left by now, but if there is this a case for virtual functions where you have classes inheriting from a common base? Is this a case for lambdas? Is this a case for writing templates? This is C++, not C. It's really hard to find a good use case for function pointers in modern C++. Auto makes your code more maintainable. Makes it so that when you make one change, you don't have to reproduce the effect of that change in 6 other places. It also helps you to declare lambdas and iterators, although if you're using a lot of algorithms, you'll be declaring less iterators than you might think. And finally, be object-oriented. C++ is an object-oriented language. If someone's giving you sample code to use shiny feature X and it has no classes in it at all, why? Perhaps you should think about using that object-oriented capability of the language, and especially when that opens up capabilities that let you rip out more old-style, hard to read, hard to maintain C features.